Lesson 5, more simplifying radicals. This is going to seem like a really tough lesson because all I'm going to be looking at today are the weird, bizarre ones I haven't covered yet. Don't let it freak you out. I'm not going to be throwing 40 of these at you on the test, but I'm going to throw a couple. And you're going to notice right away that your lesson, you need to change some of the questions because after I photocopied this, I went, oh, there's actually some better questions. So I don't think your A says 8 over 5 root 200, does it? Okay, change A so it says 8 over 5 root 200. That's going to happen about 6 more times during this. So change A. Can't say change A. Why did I do this? Because if factoring is one of the math F words, fractions is the other math F word, and there's a fraction in the front here, don't freak out. Piece of cake. Okay. Part of the reason this is tricky is because of the type font. The type font writes the fraction and then puts the square root like in the middle. The square root is not in the middle. It's on the top of a fraction because this here is technically over 1. And that's the key to doing this. We're going to rewrite this as follows. We'll put an equal sign. We're going to rewrite the 8. We're going to write an over with a big fraction bar and a 5. Jake, what do the instructions say? Simplify. What that really means is for square roots, pull any roots that are hidden inside the radical out. So we're going to take that root 200 and we're going to rewrite it. We're going to rewrite it as what times what? Oh, y 100 times 2. Is 100 a perfect square? That's a great choice. So we're going to write it as root 100 root 2. What is the square root of 100? 10. So this is really 8 times 10 all over 5 root 2. You okay with that so far, Rachel? We took the 200, we broke it down, and then we said we can take the square root of 100. In the front there, what is 8 times 10? 80. And what's it being divided by? 5. Yeah. You're not going to divide the 5 into the root. We don't divide roots by numbers. We divide roots by roots. We divide numbers by numbers. So what is 80 divided by 5? 14. This ends up being 16 and a root 2. So I will definitely give you a fraction in front of a radical on your test. And what's the trick to doing it? Just make sure you put the radical on top of with everything else. Take care of the top, and then numbers divided by what's on the bottom. Let's try another one. I don't think this is what you have for B, is it? Well, then fix it. Negative 3 over 2 root 108. That's the question we're going to do together. And I'm going to do again here the same idea. I'm going to put an equal sign. I'm going to rewrite the negative 3. I'm going to rewrite the 2, but I'm going to make sure I can clearly see that the root 108, it's on the top of this fraction. It's there. That's how I wish the typewriter would do it, but my word processor does not write it like that. It always puts the square root halfway level with the middle of the fraction, which frustrates me. Okay, what did the instructions say? Jake said it said simplify. Oh, that means I want to take that root 108 and write it as 9 and 12? Root 9, root 12. Anybody see why we're actually not done? Why root 9, root 12, while it was an okay choice, wasn't the best choice? What's 12? root 4, root 3. There's another root hidden in there. We could have, I think 108/36 goes into it. But the fact that you didn't see it, no problem. I'm just going to always get in the habit of looking at what's left inside the radical and saying, hey, is there a perfect square hidden in there? Is there a perfect square hidden in a 12? Yeah, it's 4 times 3. So this is really negative 3, root 9, root 4, root 3, all over 2. That's really negative 3 root 108 over 2. Let's evaluate the square roots. So let's rewrite the negative 3. What is the square root of 9? 3. What is the square root of 2? Sorry, what is the square root of 4? 2. Whoops. And then there's going to be a root 3 on the end, yes? All divided by 2. Let's tidy up the front. I have negative 3 times 2 divided by 2.
Negative 18.
I think the top is negative 18 divided by 2. Okay. I think what I end up with is negative 9 root 3. I could even double check that if I wanted to on my calculator. I could go negative 9 times root 3. I get that. And then I could go with the original question, which is negative 3 divided by 2 times the square root of 108. Do I get the same decimal? Then I think we're right. C. Is that the question you guys have for C? 10 root 20? Okay. It says simplify, then let's simplify. This is going to be, rewrite the 10 in front. What can I break root 27 down into? Root 9, root 3? What can I break x to the 4th down into? Wait a minute. Isn't x to the 4th a perfect square as is? Then I'm just going to rewrite root x to the 4th, but on my next line, I'm going to take the perfect square of it, the square root of it. Because when I got a 10 in front. What's the square root of 9?
3.
And then there's a root 3 left behind. See it? And what is the square root of x to the 4th? Let's tidy this whole thing up. What's outside the square root in the very front of everything? Sorry? More specific, 10 times 3 is? That's not all that's outside and in the very front of everything. There's something else that I pulled outside. It's written at the end of it right now, but it's going to end up in the front. Yeah, I'm going to have a 30, an x squared, and left behind inside the radical, in the radicand, a root 3. D, is that what you guys have for D? Yeah. Ah! No, relax. That's a fraction. Relax. Can you read this to me, Graham?
12 over 25.
No, you missed something.
Root 12 over 25.
Do you know how I'm going to do the square root of 12 over 25? I'm going to do the square root of 12 over the square root of 25. That's the, if you have a fraction and all of it is inside a root, what you're really saying here is root the top over root the bottom. I'm going to write it this way. I'm going to say, hey, this is, and I'm going to do the top and bottom separately. Root 12, how can I write that? Root 4, root 3. You awake now? Root 25, how can I write that?
Root 5.
I got to be careful. Jake made a great mistake. He said root 5. Is that not a perfect square? Then I'm going to take the square root of it, root nothing left behind. What is the square root of 25? Just plain old? 5 root 5? No. 5 root anything? No, just 5. Right? What's the top simplify to? 2 root 3. And the bottom is just plain old. It's 2 root 3 over 5. So if they give me a fraction inside the radical, I'm not going to panic. Instead, I'm going to go square root of the top divided by square root of the bottom. E. Oh! What's weird about E? What kind of a root is this? This is cube root. So I'm not going to be looking for perfect squares. I'm going to be looking for perfect what?
Cubes.
What are the perfect cubes? You know what? Let's write them off in the margin here. What's 1 cubed? What's 1 times 1 times 1? What's 2 times 2 times 2? 2 cubed. 8. What's 3 times 3 times 3? 3 cubed. 27. 4 times 4 times 4? We'll stop there. Those are the ones I'm looking for. Do any of those go into 24? Oh, I can rewrite this as cube root 8 times cube root 3, which is still cube root 24. What is the cube root of 8, oh pray tell? 2 cube root 3. That was so much fun. Let's do another one. Okay. F. 4 cube root 54. So make sure when you're doing these, you make sure you notice whether we're doing cube root or square root or fourth root or fifth root or whatever root. Probably going to be square root mostly, but a couple of cube roots, maybe 1/4 root. 4 cube root 54. First thing I'm going to do is rewrite the 4. Now, I'm thinking perfect cubes, so I don't want to go 9 times 6. 9's not going to help me here. That would help me if it was square root. What perfect cubes go into 54? Does 8? 27. So you're telling me this is going to be the cube root of 27 times the cube root of 27 times what is 54? Oh, 2. And Cole, what is the cube root of 27, oh pray tell? And what's in front already? We know what's in front already? A 4. And so what you're saying is, Duick, that's a 4, and this whole thing works out to a 3. What's 4 times 3, my child? Did you say 12?
12.
See where it came from, right? A 4 and a 3. And what's left behind inside the cube root? A 2. So if they give me the fancy word higher order roots like cube roots, Curtis, I can handle it. What if it was a 4th root? I'd be looking for perfect fourths. I don't know the perfect fourths. Yeah, but I can find them. 1 times 1 times 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2, 16. 3 times 3 times 3 times 3, 81. I'd look for those. They're not going to give you a huge one if they give you a 4th root. Then we also spent some time going backwards, rewriting them as an entire radical. That means instead of writing it as something root something, just write it as root something. Going backwards. What's in front of the root 10 in example A? Where'd the 8 come from? Where'd the 8 come from? What root must have been sitting there so that when I took the square root, I got 8? Graham.
64.
This must have been root 64, root 10. Graham, how'd you get the 64? You took the 8 and you went 8 what? or the fancy schmancy way for multiplying by yourself that begins with the letter S and rhymes with squared? Yeah, 8 squared. You know what? This must have been starting out as root 640. That's the original question. That's the entire radical that the mixed radical came from. And just if you're not sure where that came from, we went 8 squared. Y squared, square root. Try B on your own. See if you can figure out what entire radical that guy came from. I got that? Root 20. Logan awake?
Yeah.
Sure now? Sit up. There you go. Graham, can I come back to you for A? How did you get the 8? You said you went 8 squared. What kind of a root are we using in part C? Cubed? So I'm not going to be looking for squared. What am I going to be looking for, do you think? Cubed. I'll show you what I mean. They're saying when you simplified this perfect cube. Do you guys have that question?
No.
Add that question. And you probably don't have D either, so you will add that in a second. So add C. I photocopied these on Saturday, and then Monday night I was like, oh, I thought of some extra examples that I should have added. So if I want to write this as an entire radical, well, there's definitely going to be a cube root of 5. That just drops down. Where did that 3 come from? That 3 came from the cube root of what?
27.
Huh?
27.
Nice. Which means the entire question came from the cube root of whatever the heck 27 times 5 is. Sorry, what? 135, that's where it came from? Came from that. There's the entire radical that our mixed radical answer came from. D. This is an A minus, maybe even an A plus level question. So if you find this tough, good. It means you're normal. What kind of a root are we dealing with? Square root, cube root, fourth root, fifth root? Cube root. So think cubes, 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 cubes. They want me to write this as an entire radical. Well, there must have been, I'll just drop the cube root of 10x down. That's part of my answer. Where'd the 4 come from? Must have been a cube root of 64. Where'd the x squared come from?
X to the 8.
Jake is very close. Jake said x to the 8th.
X to the 6.
Ooh, Rob, what?
X to the 6.
Because I think x squared times x squared times x squared isn't x to the 8th. You add the exponents. You know what? That must have been a cube root of x to the 6th. So my original question must have been the cube root of numbers times numbers. I got a 64, I got a 10. What must have been sitting in the original radical? A 640. And then how many x's must have been sitting in the original radical? I heard 6, I heard 7. Which one?
7.
Ah, right, the 6 that you mentioned, but there was 1 left behind. Yes, yes, yes. There's the original question. If I simplified the cube root of 640x to the 7th, I would end up with 4x squared cube root of 10x. That was nasty. Turn the page. Now let me see, Mr. Dewick. You're going to do a couple of area questions, Mr. Dewick. I think what I'm going to do is I'm going to do the back page on Thursday, and I'm going to give you part of the homework assignment. You won't be able to do every question, but it's lengthy. It'll take you the rest of class, so you can work on it, and then we'll tackle the rest of it on Thursday. And if we play our cards right, maybe a 4-day long weekend with no homework. Okay, so let's pause the video right here. Quick look at assignment number 4, please, the one that I just gave out. Very quickly, number 1 isn't asking you to evaluate anything. It's saying identify each radical as a mixed or an entire. What do we mean by mixed? Which one of those, there's 4 there, A, B, C, or D, which ones of those are mixed radicals? That's a mixed radical, that's a mixed radical. Which of those are entire radicals? That's an entire radical, that's an entire radical. What do we mean by a mixed radical? A mixed radical has stuff inside the square root, but it also has stuff where? Outside. It's mixed. Okay. Number 2, convert the following radicals to mixed radicals in simplest form. So this is like we've been practicing. So you'll write the root 8 as, I think, 2 root 2. You'll simplify these. And you'll do that all for the front page and on the back page. When you get to number 4, now you're going backwards. Now you're going to entire radical form. So now instead of having 4a 2 root 6, you're going to write it as a single square root of something. I think root 24 if I'm doing the math right. That's all fair game. The weird ones, which I haven't talked about yet, are number 5 and number 6. So the Pythagoras ones we'll be doing actually next class. That's the part of the lesson I didn't get to. Number 7, now we're getting into cube roots. We practiced a couple of those today. See if you can handle cube roots, rewriting those. Number 8, a 4th root. Don't freak out. A cube root, a 4th root, a 5th root. See if you can figure that out. If not, I'll help you. Number 9, going backwards, expressed as an entire radical. Means we want you to write it no longer as 6 root y, but as 1 big square root. Or 1 big cube root. And these are pretty messy. Okay? I have answer keys for this done. I'll have a couple of those floating around. Your first job, if you haven't finished assignment 1, work on that in class. I'll have 5 answer keys for that floating around. Your second job, tackle assignment 4. You can't do the Pythagoras ones, but everything else, in theory, you should be able to do. Some of these are nasty. Specifically, anything past about number 7 is meant to make you cry. That means you should find the test a lot easier.
So we're working on it Thursday too?
I'm going to be doing, finishing off the lesson, giving you some time on Thursday, and then I also have a big review. Thursday, you'll probably get a take-home quiz, too, but I'll try and give you time in class to get that done.